Okay, hello everyone, and thank you so much for joining us this afternoon. Today on this webinar, we'll be discussing real-time decision-making and predictive analytics, and we'll specifically be looking at a fintech use case. Today at the Yhat headquarters, you have myself, that's Elise Breda, as well as Charlie Hecht. He's our Director of Sales and Customer Development. Colin Ristig leads our product management team. And you also have Leah, who is Head of Security. So if you hear her in the background, she is here as well. On the agenda today, Charlie will be starting out, and he'll be providing an overview and insight into the data science lifecycle. He'll be taking about 10 minutes to discuss how data science is generated and then critically integrated into production applications. After that, he'll be turning over the virtual mic to Colin Ristig, who will be taking us through a demo with a fintech use case. And today we'll be looking at how Faradam Bank deploys the predictive analytics that support and are behind their web and mobile lending businesses. And that's both consumer and business loans. After that, we'll be taking live Q&A, so feel free to jot down in the bottom left hand of your screen any questions that arise, and I'll be moderating that chat, and we'll be sure to cover those in the 45 minutes that we have, or happy to stay on the line. And just one final housekeeping item before I turn it over, I will be circulating these slides as well as a video recording shortly after this webinar. So with that, I will turn it over to Charlie.
Thanks, Elise. Folks, really excited to be chatting with you here today. Like Elise mentioned, I am the Director of Sales and Customer Development at Yhat. Who is this webinar for? So we want to direct sort of the conversation here to three different sections or groups of folks. Folks that are data scientists, right, or quant analysts, anybody that's working with, doing statistical computation. Application developers, so engineers or folks that are actually developing both web and mobile applications for production use. And then also decision makers. So when we're talking about decision makers, we are talking about sort of folks that are internal decision makers within an organization that hand sort of statistical problems down to the data scientists and then eventually up to application developers. So what we found at Yhat in working with our current customer base and then having conversations every day with folks in the space is that the sort of traditional data science lifecycle begins with a question from a decision maker. The decision maker will come to an analyst or a data scientist and say, hey, we've got this issue, this problem. I want you to look into it and see if you can come up with a solution. So that data scientist or that analyst goes away and embarks on what we like to refer to at Yhat as the data science lifecycle. And any data scientist knows that most of that lifecycle in terms of time is spent doing the sort of beginning part where you're munging, right? Or just getting data in a place where it's clean. And at this point, sort of towards the end of this lifecycle, that data scientist is coming back with an insight, right? Could be a long-running script or a predictive model. And we found that at this time, there's a now what clause. The business decision maker says, great, but how do we get this into a production setting or a place where it can be leveraged by the business? So like I talked about it just a second ago, when we're talking about the stages of the data science lifecycle, where you start with raw data and you end with a production sort of real world scoring application, most of the work on the data science perspective is spent data munging, right? So cleaning data. And then sort of as we move through towards the later stages, there's still a significant amount of work that goes into building these insights into production. But again, that majority of the work is being spent on the back end. If we compare each of those stages to how much sort of business value they actually add, there's really no value that the business sees from those insights until the very moment that they're seen in that production setting, right, or implemented into production. And so in that sense, the high cost that's going in on the back end never really sees ROI until the very moment that they're implemented. So Yhat sort of has seen, like I said, amongst our customers and has stepped in to really try and solve this problem. And when we've spoken with folks in the industry, we've seen that they're solving really two major problems. The first problem is, how do we effectively manage and standardize workflows? How do we get a team to collaborate? A team built of data scientists or statisticians that maybe all use different tools when they're conducting research. How do we get them to conduct their research in sort of an organized fashion in one place and not be limited on the IT side? And sort of on the opposite end of the spectrum, in the later part of the data science lifecycle, how do we effectively implement those analyses or those insights that we've derived during research into production? How do we get data scientists to actually implement those analyses and those insights without having to draw a lot of IT or engineering budget? And so again, we've set out to solve this problem at Yhat, and we've developed those two products. Let me scroll back here. Science Cluster and ScienceOps. We'll be focusing on ScienceOps for the purposes of this webinar, and it's our tool for helping teams to integrate those insights without having to involve IT or engineering. And so what we've tried to do, now that we come back to sort of the cost of complexity chart, is show that with ScienceOps, what we're doing is we're taking away the work from the business side in the later stages of the data science lifecycle. We fully expect and want data scientists to focus on the statistical part of their job, but we don't want them to have to focus on the engineering part of the job. And so that's where we're coming in. At this point, I am going to kick it off to Colin. Like Elise mentioned, Colin will sort of get into right here in the next few slides a specific customer use case and then later into a demo. So Colin, please take it from here.
Thanks a lot, Charlie. So going on to the integration and real-time scoring aspect of deploying predictive models, we're going to first look at a use case by one of our customers, Faradim Bank. They're a large European lender. They have applications that run in, I believe, up to 20 different countries. And kind of discuss how a predictive model can be deployed and used in a real-time application that's specific to a lending customer. So just to kind of give you some context to how Faradim uses ScienceOps to deploy models, we'll first kind of take a quick look at their webpage, which I've got here. And you can see here, as a hypothetical loan applicant would want to come to Faradim and say, get a short-term loan. They're given a slider here and then an apply now button. And kind of the logic that ensues after this apply now button is presumably there's an application that runs on the back end that is, capturing user information, maybe third-party credit data, looking at, looking for true fraud, as well as trying to assess the actual risk the candidate themselves has. And then going kind of back into the predictive modeling side of things, how does the predictive model that will presumably make all of the decisions and evaluate all the risks of an individual applicant be rendered into this user-facing web application? So going back to our slides now, this is the way that Faradim specifically uses the ScienceOps platform for deploying and rendering a decision when a loan applicant submits their information. So here on the left, we'll have a consumer credit applicant, in this case using a mobile device, inputting the loan amounts, the terms of their loan, the rate at which they'll pay them back, in addition to a bunch of personal information. That then gets sent to Faradim, where they store these sort of things in their databases, do some general kind of data transformations. And then finally, once the data is all prepped and ready to go, it's time to assess the actual risk of the individual candidate. So at that point, the information will be kind of appended with, say, FICO scores, Equifax, Experian, any sort of third-party data that would potentially increase the validity of the applicant or enhance kind of like the risk and attributes of the applicant. From that point, the data is then passed into ScienceOps, which is hosted within Faradim's server infrastructure, where it runs through a custom proprietary model that they've deployed to ScienceOps, which I'll show you how to do in a moment. There's a credit score that's generated, and ultimately a decision based upon the credit score that's produced. So if the value is, say, over 700, they'll automatically approve the applicant for a loan and continue them through the UI pipeline within their actual mobile application. So now that you kind of have some context as to where does a predictive model in this specific use case fit, I'll jump into a kind of programming language, which many of you will be familiar with, R in this case, as to we actually deploy a model. So let's go to RStudio. For those of you who know, this is R. It's a programming language. It's a very popular statistical programming language. We also have support for Python as well, so very similar in concept. The main objective, obviously, is to create some sort of algorithm to kind of, again, estimate how risky is this loan applicant. I'm not going to go through the details of this specific model. You can see there's quite a bit of code here, but the main idea is at the very end of my script here, I've created a function that, again, it's going to categorize this applicant and determine, the probability of whether they default on a loan or not. And as we've kind of alluded to previously, one of the big kind of hangups at this point in the data science lifecycle is how do I take this R script that you see here on my laptop and embed it into an application that's used by people, around the world in various countries who want to get loans and have to be processed by this application. And that's exactly where ScienceOps comes in. So at the bottom here, we're going to import some Yhat-esque libraries and then build out a function that is going to be executed and interacted with via just a standard REST API that will then determine whether this individual applicant will be approved or not. So at that point, we'll then wrap everything up, send it over to ScienceOps, and from there I'll kind of discuss what the integration process looks like and how we can actually invoke our model in a real-time use case. So I'll execute this function, and then let's jump over to the ScienceOps UI. So take a step back. This is the model overview page that we see within ScienceOps. You can see here I have two models deployed. One is a hello world, which, as it sounds like, produces a hello world. And then here we have the lending club, or the kind of credit model that I've been developing in R. So you can see here I have 5 different models. And one thing that is really important here is to invoke any sort of model within a web framework or any sort of application, you want a standardized form of how to do that. So what we've done at Yhat is with ScienceOps, we pass in just a standard JSON object that can be curled from a command line, built in from a Ruby application, requested from a PHP app. Any sort of programming language can invoke this exact request. And what basically happens when a web app or a developer decides to query this predictive model, they'll send in this JSON here on the left. We'll click execute, which will then execute the prediction. And over here on the right, you can see exactly the output from our predictive model. So we'll see we're not declining this applicant. We have a 1.5% probability of default, and then a credit score, as well as the kind of metadata about the model. So this is an individual prediction, the model name, and then the actual version of the model. For example's sake, I'll change the FICO score here of this hypothetical applicant, and we can see here by watching the probability of default that it will change. So I'll click execute, and you can now see that we've got a probability default of 19%. And if we take that example even further and lower their score even more, you can see we've also incorporated some business logic here to indicate that their credit score was too low, and then we've declined them as an applicant. But again, going on from there, how do we integrate this model from this point into the web application? And that's where this integration tab comes in. So you can see here we have support for every single basically programming language that can invoke a HTTP request. Salesforce, for example, many customers of ours use a CRM system to manage their credit applicants, so you can invoke models from there. Java, Ruby, PHP, and so on. Another really critical thing specific to finance is the ability to kind of quickly roll back or control the version of a credit model that's online. If a credit board makes a policy change, you want to be able to quickly deploy a new model or roll back to a previous one. So I can do that simply with the click of a button here, and that will basically do a hot switch from my version 4 to version 5. Expanding on that, another really critical thing with deploying predictive models is prediction logging. So how do I verify that a loan applicant who came through my system in, say, January, why was he or she declined? Why were they approved? What were the inputs and outputs of my predictive model at the time when this person applied? What version of my model is running? And how can I go back and verify the predictions that I've made to kind of validate the individual model that was online at the time? So you can do that here, configuring prediction logging, and every single prediction that is passed through ScienceOps will be tracked and stored. We also have robust monitoring services, so all of the models as well as the hardware that the servers run on can be monitored in real time. And all of that kind of adds to just keeping a production system for doing predictive models as well. Going back now to our example, so if we look, we have our lending club model here. It's working all within the UI. But now, again, kind of harkening back to the data science lifecycle, how do we then build an integration to an application, a la the example I showed you with Feratum? So going over a tab here, you can see this is kind of like a mock web page. You probably wouldn't, in realistic situations, have users submitting their own FICO scores. But for example's sake, we can see that we're capturing here the revolving credit line utilization of an applicant. People can submit, whether they rent or own their home, their annual income, and then finally, the kind of most critical part, the loan amount. So, as say, if we're Yhat, for example, we're a hypothetical fintech company giving out loans, we could build an app like this, and simply by clicking this score button, we'll invoke our predictive model. You see the similar looking JSON over here with the probability of default. And then we've also kind of whipped up just a simple distribution of the credit applicants we've seen to this point. So, an underwriter or someone perhaps in a credit department could look at, where does this individual applicant fall on the spectrum of all the applicants that we've seen to date. So that is kind of at its core what Yhat enables, or ScienceOps specifically enables you to do, is take an R script or a Python script that invokes some sort of predictive routine, analytical routine, a model of some sort, and then call it from within an application. So it could be a web application, a mobile application, a CRM system, and then basically execute on some business logic that a analyst of some type has created. Going back now, so that was kind of a quick demo of how ScienceOps works. There's a whole host of other features that we've built out, such as just all sorts of monitoring. We built out integrations for unit testing as well. So as you deploy a model, you can run several thousand scenarios through it, ensure that it passes them all, so that as you push a new model live, it can be embedded in an application, both with confidence, knowing that the validity of the statistics are there, as well as knowing that the server infrastructure and the hardware that's running these models is up and being monitored in real time. So at this point, I'll hand it back to Elise, and we can kind of take it from there.
Great, thanks so much, Colin, and thanks to everybody who's on the line. That wraps up our demo portion. We're going to turn it to Q&A at this point. So I have a few questions that have already been, but feel free to keep sending those over. The first question that we got, can the software be installed on-premise? So if one of you wants to speak to that.
Yeah, great question. So particularly for fintech companies and any companies dealing with proprietary data or sensitive data, we built out our platform to be installable basically anywhere. So Amazon, for example, is a really popular cloud solution. We support that, as well as true on-premise data centers. You know, if you have a server running in a closet down in the IT department, we can install on there as well.
Perfect. All right, question number 2 that we had come in, and I think, Colin, you started speaking to this, but maybe we could elaborate a bit. How do you deal with increased throughput to models? So say it's lending, maybe consumer lending is going up with the holiday season, or it's throughout and expanding into new countries. How would you deal with that increased throughput?
Yeah, that's another question. So I kind of glazed over this, but ScienceOps is a distributed system. So there's a master node and then a number of worker nodes that can be used to host models on. And what basically happens as a prediction comes in and hits the master node, we load balance across a series of worker nodes. So in terms of scalability, what that allows us to do is you can add additional worker nodes as your throughput needs increase. So say it's a seasonal thing, you can add additional worker nodes and then increase the number of kind of models, if you will, or replicas of a model type that can then be queried and basically increase the rate at which you can predict on a specific topic.
Great. Another question that we had, and this one might be of interest to the fintech crowd, can we use our own custom packages in environments when we're using ScienceOps?
Yeah, that's another great question. So for both Python and R users, it's, again, fairly common for people to write proprietary R or Python packages. Several of our current customers have specific C bindings that they'll invoke with Python and R. All of those things can be invoked within a specific predictive model. So the short answer is yes. Any sort of proprietary package or algorithm or library can be invoked from a model and lives within that kind of model environment.
Perfect. And let's see, we have one more trickling in. How do your current customers set up model auto deployments?
So auto deployment is something that some of our customers use, especially those who are using recommenders. So if you have a set of data that is changing constantly, you may want to retrain your recommender algorithm to encapsulate changes in inventory or changes in stock. So what they basically do is trigger a deployment to occur on an hourly basis, usually with cron or with our other product, Science Cluster, and basically trigger the model to be retrained and redeployed on an automated basis by basically rerunning that script that generates the predictive routine.
Great. And one last question. Today we were focusing on fintech, but what other industries has ScienceOps been used in?
That's a great question. So fintech has kind of been our sweet spot, but we have worked with the educational institutions. So the Education Advisory Board, or also known as the Advisory Board, uses predictive modeling to estimate whether students are likely to drop out or not. That's done in kind of like a batch scoring style. Predictive models estimating recommending products. So Turo, which was previously Relay Rides, they recommend car rentals to customers who appear on their webpage. So based upon a series of clicks or so on, they will recommend a user rent a specific car or something like that. Lead scoring is also another really common one. So if you have, say 50,000 leads for a sales team, how do you choose which lead is the best person to be contacted with, and how do you rank them and distribute them to sales reps? That's another common use case too.
Perfect. All right, well, it looks like that is the end of our questions so far. We'll stay on the line for a few more moments if you do have anything. Otherwise, as you see here on the slide, you can email either Charlie or Colin, and that's just Charlie or Colin respectively, at yhathq.com. I'll be sending out the recording of this as well as the slides shortly hereafter. And with that, we'll wrap up and just thank you for your time today.